What you're about to learn right now is a technique called direct substitution for finding the limit of your function at any point. So just to recall, we talk about limits as x approaches a certain value, and the limit is technically a y value. So for instance, in this function, which is defined by this equation here, for this function, if I were talking about x approaching the value 1, then I'd be looking at the actual function values themselves from the left and from the right. As my x's approach 1, my function approaches -2. And so I'd say the limit at that point is -2 simply because my function is approaching that value. So limits are y values as x approaches a certain value. So try and keep those two things separate in your mind as you work through these. Okay, so the first example that I'm going to give you is an example where you can directly substitute x values into your function in order to find the limit. Now, this technique is going to work for what we would call well-behaved functions. This is an example of a well-behaved function because it has no holes and it has no asymptotes, no other strange behavior. In fact, for any x value that I choose, if I were to just plug this value, say 3, into that equation, I would get this point here. And as you can see, that value, that y value there, is the limit of my function as x approaches 3. From the left-hand side, the function approaches that value, and from the right-hand side, the function approaches that value. So for well-behaved functions, if I want to know the limit as x approaches 3, I can just plug it right into my equation, get the y value, and it's always going to follow that behavior. So let's do a couple of examples. Let's find the limit as x approaches 3 for the function f of x. And essentially, that's going to look something like the limit as x approaches 3 for that equation right there. X squared minus 2x minus 1. Now, I've chosen the value 3 because it's a very nice point on my function. I expect the output to be a value of 2. That's 2 on the y-axis. So now I'm going to show you that I actually do get that value 2 simply by plugging 3 into the equation. When I actually take the limit, I no longer have to write the limit as x approaches 3 because I'm actually taking the limit, what we call taking the limit. So that's a matter of plugging 3 into each one of these x values. So I get 3 squared minus 2 times 3 minus 1. 3 squared is the number 9, minus 6 minus 1, which is 9 minus 6 is 3, and 3 minus 1 is 2. And that's exactly what I expected the limit to be at that point. So I want to be really clear again that for well-behaved functions, there are no jumps, there are no holes, there are no asymptotes, there's no like weird from the left, from the right behavior going on like that. And so I can just take the x value, plug it into my equation, and I know that the limit is going to be equal to the function value for these well-behaved equations. All right, let's do another example. Let's just say I wanted to evaluate a limit from the left or the right. Now again, because this thing is continuous and well-behaved, I can evaluate limits from the left and the right by directly substituting in the value that I'm interested in. So let's say I'm interested in this value for -1. So I'll say the limit as x approaches -1, and let's say from the right, of x squared minus 2x minus 1. And because I know this thing is a parabola, a well-behaved function, I can take -1 and plug it right in. When you actually plug in the value, you no longer have to write limit, this limit notation. And then simplify. So this becomes +1 plus 2 minus 1. And that gives me the value 2. So over here at -1, I get that same y value back. Just symmetry of my parabola, or defines this as being a 2 as well. And so from the right-hand side, I know that the limit is going to be a positive 2, because that's exactly what the function value is, and this function is very well behaved, everything kind of works together and acts as expected. So always attempt direct substitution anytime that you're working with a function, especially functions that you're not super familiar with. If you know that it's a parabola or a cubic function or something that you know in your mind is very well behaved, there's no asymptotes, there's no holes or jumps, go ahead and try direct substitution. Even if you're not familiar with the equation, try direct substitution anyway. Um, and we'll talk more about techniques in case this doesn't work. And I'll show you situations in the next couple of videos when this would not work.